Now we are.
Solve for OH on the K.
What does hydroxide equal?
On the K.
Yes. Times the concentration of F minus over concentration of HF. This might be much easier to do. Because Evan, you might have had it right, and I was getting lost in the weeds. One of the two. What is the concentration of H3O plus? Ka times concentration of HI. And it can't be I because that's a strong acid. That would be wrong. Over F minus. That would actually be a lot easier to do because then we could take our equation. Kw is equal to what two things multiply together? OH minus and H3O plus. Take those two values, substitute them in, and then multiply it through. And then tell me what you get. Hydroxide, take the hydroxide, what it equals. H3O plus, take what it equals, put them in, multiply them together, what do you get?
Wait. Is it KB times... Oh, you flipped it somehow. Something happened. Okay.
Isn't it just K times KB?
Yeah, it is.
Wait, what happened to when KB... Because right now you have KB with the base. What happened with KB with the acid?
Oh, I abandoned that line because it got too complicated.
Okay.
I think it would have involved square roots at one point, and I didn't want to do that. So this is an easier way. Isabel, what does it end up being?
Ka times KB.
Ka times Kb. If we have hydroxide there, that is Kb times F minus over HF. And then H3O plus is Ka times HF over F minus. What cancels out? F and the HF. Kw is equal to Ka times Kb. Did you just, we just derived a whole new relationship.
Wait, can you scroll up a little bit?
Mm-hmm. Pull out your data table. Yeah. Pull your data table.
KW equals KH times KB.
Yeah. We now know Kw equals Ka times Kb. That is a new relationship. Do we give you KBs on your data table?
Yep.
Take a look,
Wait, so
Mr. Yep.
Oh, sorry, you did KA.
You do have Ka, and you know Kw. If you look at your data table,
You do KA.
they give you Kw
Where's the KW?
because the reaction of water is the Kw. It's the same thing, so it's there at 25 degrees Celsius. They give you the Ka of all these acids. So if I asked you for the Kb of IO3 minus, how would you calculate that?
KW divided by KB.
Kw divided by
Wait, what's the KW?
Ka. So Kb is equal to the Kw is equal to Ka times Kb. KB is equal to KW divided by the KA, which means the KD 1.00 times 10 to the minus 14. You look up the KA. If you have the base, it better be on the base side. So we take that KA for its conjugate, and we divide it into 1.7 times 10 to the minus 1. And now we will have the KB for that particular base. Something times 10 to the 13, I presume. Because they both equal through the KW, if an acid is very, very strong, its conjugate base will be very, very weak. So when you calculate the KB from a high Ka value, it'll end up being quite low, which is another reason why the strong and weak are opposite on either sides. So although this is written as if they're all acids, you can take all of these and go, oh, plus H2O goes to OH minus, and then treat it like a base table and use the Ka and the Kw to calculate the Kb's as you need it. So they only need to give you the acids. Once you have that, you can calculate the Kb relatively easily. Find HSO3 minus on the table.
Sorry, I was trying to follow and then got lost.
Mm-hmm.
Is this what you wanted
Yeah.
to
Yeah, Michelle can see. Where's HSO3?
It's like no sulfurs. It's a conjugate like
Sulfurous acid. So it's in two places.
It is?
Yep. So we've got HSO3. You just found it with sulfurous acid right there. So it's there. Where else is it? Yeah. So we have it here. If I ask you if you are doing HSO3 minus plus H2O, if it's on both sides, what kind of a molecule is it? Close. Amphiprotic. If you are using it as a base, and you need the Kb, which of those Ka values do you use? Because you have two choices now. If it's being used as a base, which one has its Kb? Which one's the base one?
The hydrogen sulfide, yeah.
The
No, the other one, the sulfurous.
The sulfurous. This is where it's acting as a base. This, if you calculate the Kb from this, you are calculating the Kb of that species. So when you calculate the Kb, you're calculating the Kb of the species on the right. So the Kb from here will be for SO3. And students can go through and they find the first SO3 they have, they calculate the Kb, and then they move on. Make sure it's on the correct side. If it's a base, it should be on the base side. If it's on the base side, you're good. Relative strength. There's something really to write here because we've done the table. A strong acid is 100% dissociation, has an undefined or infinite Ka, because 100 divided by 0 is infinity, in my view. For weak acid, the larger the Ka, the stronger the acid, which we've seen. So for very high Kas, you have stronger acids. We now have the table. For weak bases, D, perfect. The greater the what, the stronger the base?
Greater pH. Greater pH.
What were we just talking about? K, which K value?
But that's also true.
KB.
Like, that's also true, though. The bigger the pH, the stronger the base.
The table does not have the KB. The KB can be calculated. I am never going to ask you to derive this relationship. That was purely for your enjoyment. But you do have to know the relationship. We used math to determine a relationship. And it was fun. It was fun.
This one.
Let's see that.
What?
Let's see that. This is good. At 25 degrees Celsius, which is everything that we're going to be doing on your table. Why are you packing up? We go to 1:15 and we still have 10 minutes of our practice problem. Yeah. Let's calculate some KBs. Showing all your work. Calculate the KB of F minus. And I'm going to put you into groups because it makes it way more fun. Cole, you can pick what group you're going to join. But you definitely need to get up and walk around after that amount of math. Show me your calculation on the board. Calculation of the KB of F minus, which we've just derived through, and the calculation of the KB of HCO3 minus. Evan, where are you going?
Oh, yeah, yes. I did.
Minus 28 is awfully small. When two numbers multiply together, it should come up to the minus 14. One is minus 4. I think you've done a calculator. Remember that exponents add, so like you should get somewhere around, regardless of which way it is, either minus 18 or minus 10. Show me what you got once you're done. There is one more task before you go. KW is KA times KB. So you can look up the KA on the table.
Wait, KA of F. Wait, I have table right here. So there's
So you want to calculate the KB of F minus. Find it on the base.
Wait.
Because you're calculating the KB, so you want to find it where it's acting as a base. Well, that seems a lot better. I gotta see your second. I want to see your fun. What do you got? I need to see the actual number. What we got for actual numbers? That's good. What do you got for your second one? That's for the first one? What do you got for the second one? Oh, okay. So the second one is not 1.79 times 10 minus.
What?
Why'd you use
Just
4.6?
change your answer after we wrote something down.
Yeah, because on the base side. Other people saw it on the acid side.
Yeah, I kind of did that. Yeah, I realized.
One, three, that's the one. Yep. There you go. What do we got? 2.32. Yep, you're good. Yep, that's really right. So everybody else is getting 2.3 times 10 minus 8. They have a different number below you. 2.3 times 10 minus 7, you get 5.6 and minus 11.
Yeah.
That's where you're at. So when you look at, where's your table? Okay, where's your table? Who's in your group? Everybody who's in this group, get on back here. What are you doing? Matt, are you in this group?
No, also this one. You can check the.
No, it's okay. Use 5.6 10 minus 11. The reason that's not right is you found it on the acid
Okay,
side.
yeah, let's go.
So you're, that was the KB for CO3 minus 2. You gotta find it.
Yeah, you have to.
Yeah. Because the base, you have to find it on the base side. Where's your table that you're
Wait,
using?
do you know Mattson? He has like the.
What's your new file?
So, HCO3, where's HCO3 4.7?
Yeah, Thomas is like, I was with Mattson one time. He was like, oh, like, we're not. Okay, then yeah, Mattson's good.
Where's
Leadership.
What's your new file?
Here it is. So the reason, Preston, you have to find it on this side and use that number. You were finding it on, it's a fairly weak acid, I think, or is it strong? Down more? Where is it? Oh, there it is. You were finding it here. So when you calculate this KB, that's the KB you're calculating. You got to find it on the base side. Good. Excellent.
Mr. Newfeld,
Yes?
are you okay if we always know our lunch technically starts at 1:15? It's really annoying.
What? What do you mean everybody's lunch starts at 1:15?
Yeah, but we're supposed to be like sat with food at that point.
Well, what I was about to do is we have a square that looks like this. And three equations. So this is added onto that square of all the equations. Show me how you go back and forth on all those calculations. The chemical formula for both ways or one way. If you only need one, you can just show me the one. If it's one you need a separate one, show me the two, and then you can go as soon as you show it to me.
What?
What are those formulas?
What are you asking?
I want all the formulas. How do you go? What's the relationship? How do you go back and forth between here? How do you go back and forth between here? Just fill it in and show it to me. And then you can go. As soon as it's filled in. You're good to go.
Wait. Don't put that
You need the other directions for those ones. Those two work. Because they'll go either way. Yep. I think so. I am looking at them fast, so double check.
Marcus, what is it? Wait, so we're here. I can't tell you. No, it is.
Oh, you're going to the old one. I have to see it written on that page of this. I have to see copies. Because I want you to know them.
But I do know that.
Oh, good.
Can I tell you right now?
No, you have to show me on your.
I really don't understand.
That's the old one. I want this one. Yeah, on this page. For example, your top should look like this. Because that is the relationship between those two values.
Done.
And before you go, I need all of those orange things cleaned off the roof.
How we get that high?
I don't know, but you got them up there.
Keep up room. That wasn't me.
It's everybody in this row. That row is fine,
Look at my.
but everybody here has to stay.
Look at my.
I got this. Don't worry.
Just the POH, OH, you're missing one of the relationships. And then cleaned up off the floor.
But what's the relationship between these two?
The gentleman who cleans this classroom
That one's gone.
puts a heck of a lot of extra work into things. I do not want to make his life.
It's
any
kind of
harder.
it's kind of pretty though. It's about something. It's kind of like
You were actually damaging the tile, so no, it's not actually all
kind of
that
decoration.
great.
Okay. It's already styrofoam.
Okay, Mr. Nicola did it.
KW, it's not a KW, but it's that one. Yeah, that one works. And they are a log and answer log. Of what? Just show them.
Wait.
Yeah, okay, write it in.
I got that John.
I was gonna be able to look it up later. But you're not done. You have to show it to me. That's not. What is HW? There's no equal sign.
Equals. I
Where's an
don't
equal
have a
sign?
lot of space to work with. Here, equals. Here.
KW equals PH minus.
No, that is a dot. That is a dot. That is a dot.
Yours looks good, but you need to help pick up that orange thing.
I just do any other.
Oh, that's terrible, then. It shouldn't be a multiplication. Sounds good, though.
Yo,
Yeah.
what is this one?
What? Oh,
Times POH, not PH times POH.
Why are you making these? And who is making these?
I don't even know how to make them. I'm not gonna lie.
Because this is what I saw you doing when you were bending these.
Second ideas.
Yes, Evan, could you please go around, make sure these are all cleaned up and put them into the jar?
14.
You get the last one out? Yep, yeah, okay.
You gotta lay a little bouquet over
Okay.
Okay, yeah, and rowers can definitely go now.
Great.
It's not coming out.
Got that. Here.
Okay, anybody who was involved in making those, please clean up all the orange pieces on the floor. We cannot do that. There's definitely some more on the floor.
Who was involved in making those?
I don't know.
I don't
who's
know.
involved in making these.
Who was involved in making Portia, were you making them?
no, I didn't really see anyone make one.
I think they just
I
appeared out of
literally saw
nowhere.
Evan and Matt making them.
No, who was making these?
I think I was just.
Good to go.
That's low-key disrespectful.
I was just like handling them though.
I think they just
I
appeared
saw you
out of
making them.
nowhere.
I don't think so.
Yeah. And then there was the laughing because you were throwing them up.
I low-key got caught red-handed. I was throwing. I'm like a distributor, not a. not
You are randomly damaging things.
I was in the
I need
supply
frustration signs in the top ones and an equal sign. Other than that, you're good. Put in the math stuff. Yeah. Double check. The people who clean this building, they didn't hire any more people, and they like pentupled the amount of windows. So they are expected to do far more work and are under constant stress. Thank you. Somebody. job is the game.
Have a good day, son.
What?
Have a good day.
You too.